Ever dropped your phone and watched it bounce instead of shatter? That's impact resistance. How well something survives a sudden hit. Some materials, like glass, break easily. Others, like the plastic in helmets or car bumpers, absorb shocks and protect us. Impact-resistant plastics are everywhere, from packaging that cushions deliveries to the dashboards in our cars. Without tough plastics, everyday items would break far more often, and safety gear wouldn't keep us safe. The secret? These plastics spread out the force of an impact, so the energy doesn't concentrate in one spot. That's why your helmet doesn't crack on the first fall, and why your packages arrive intact. Impact resistance isn't just a lab concept. It's a property that keeps our products reliable and our lives safer. From milk jugs to skateboards, the toughness of plastic matters. It's science you can see and feel. So, what is impact resistance? It's a material's ability to absorb energy from a sudden force without breaking. High impact resistance means a material bends or deforms instead of shattering. Low impact resistance? It cracks or snaps. Engineers use standardized tests to measure this toughness, so they can pick the right plastic for the job. The Charpy and IZOD tests both use a swinging pendulum to strike a notched plastic sample and measure how much energy it absorbs before breaking. The drop weight test is even simpler. Drop a weight onto a plastic part and see when it cracks. These tests mimic real-world accidents, like dropping your phone or bumping a car. By measuring how much energy a plastic can take, engineers can compare materials and make smart choices. It's controlled destruction for science and for your safety. That's how we know which plastics can take a hit. Let's zoom in on the IZOD and Charpy tests. In the IZOD test, a notched plastic bar is clamped upright. A pendulum swings down, hits the notch, and the machine measures how much energy the plastic absorbs before breaking. The Charpy test is similar, but the sample lies flat like a bridge, supported at both ends. The pendulum strikes the middle, right behind the notch. Both tests use the notch to focus stress and make the break predictable. The less the pendulum swings after impact, the tougher the plastic. These tests help engineers compare plastics and spot weaknesses. Charpy is great for materials that behave differently depending on direction, while IZOD is a classic for general toughness. Simple, repeatable, and essential for designing safe products. That's how we turn breaking things into better engineering. What makes one plastic tough and another brittle? Temperature is key. Plastics get brittle in the cold and flexible when warm. Thickness matters too. Thicker parts usually absorb more energy, but too thick can make them rigid and prone to cracking. The internal structure is crucial. Some plastics, like polycarbonate, are naturally tough. Others, like polystyrene, are brittle. Additives called impact modifiers, tiny rubbery particles, can boost toughness by stopping cracks from spreading. Design counts. Sharp corners create weak spots, so engineers use smooth curves to spread out impact forces. Testing at real-world temperatures and thicknesses ensures plastics perform as needed. The right mix of material, additives, and design makes plastics strong enough for helmets, bumpers, and more. It's a blend of chemistry, engineering, and smart design. That's the secret recipe for tough plastics. Why all this testing? Because safety and reliability depend on it. Impact tests ensure products, from hard hats to car parts, won't fail when it matters most. Engineers use test data to pick the best materials, improve designs, and even compare recycled plastics to new ones. Better testing means longer-lasting, safer products, and less waste in landfills. Tough plastics save resources and protect people. Every helmet, car door, and phone case is tough by design, not by accident. Impact resistance is proof that engineering makes our world safer and more sustainable. Next time you drop something plastic, remember, it's science at work.